All right, we're going to talk about why you should build a robot with MicroPython, and a correction on the title is actually microcontrollers, not microprocessors. We'll talk about those in a second. But before we build something together, who has thought about building something like a robot in the past? Several people. Okay, quite a few people. Who has stuff like this laying around in their house and you haven't actually maybe made something with it? I know I've had a lot of Raspberry Pis. You maybe have, is what you're saying?
I have some Raspberry Pis. I haven't used them all.
Yeah, you can never have enough is what I keep ordering them, even though I haven't used the ones I have. So quite a few people, I think, resonate with this picture and maybe building stuff, maybe not building stuff. A few reasons why you should build a robot. It's fun. It can be really educational. It's actually what got me into programming a long time ago, was building stuff with robots and microcontrollers. And then there's also a lot of practical applications for maybe like your personal use case. What did you build?
Radio-controlled turtle robot.
That sounds awesome. Radio-controlled turtle robot.
Yeah.
Was it fun?
It was fun.
Yeah, exactly. Great. And did you learn a lot?
I learned a lot.
Excellent. Yeah. All the great reasons why you should build a robot. And then also professionally, like there's a lot of applications if you're working in hardware and stuff where you might actually need to do something repeatedly, and you can use microcontrollers to do that. And I've done both. And today we're going to show kind of how to build this messy looking robot. It's kind of messy looking on purpose, and I'll talk more about this when we get to building it. But a personal example, has anyone ever played Vermintide before? Maybe not very many people. Well, Jason says yes. You have to open up these chests, and you could click or press the space bar. And I had thousands of them, and they would only open up one at a time, so it's a lot of time. So I built a robot to kind of do that for me. This is just a servo doing something at increments of time, thousands and thousands of times. So for me, this is a great personal time-saving thing while I could still progress in the game. I'm not sure if that counts as botting. Do you think it would get me reported if I post this somewhere? Yes, no? No. People say no. Great. Okay, so I could do this in RuneScape and get to 99 and be good? Maybe, maybe not. We'll find out. I might try it and see what happens. But I've also done something very similar to this in a professional setting where I actually did need to press a piece of hardware thousands of times and then actually use a sensor to monitor if something broke or not. So just showing like this is a fun little thing, but also there's really good practical applications that you might be able to use this for as well. First thing we need to know is what is a microcontroller, or MCU, not the Marvel Cinematic Universe microcontroller. It's a self-contained computer on a integrated circuit that usually includes like the processor, memory, we have RAM and storage, and then inputs and outputs. So we'll talk about some of these pins later, but all these pins coordinate to things like digital out, digital in, analog in, and you can do cool stuff, measuring things and performing actions with them. So there's a whole bunch to choose from, like Arduino. This is a Raspberry Pi Pico. I really like them. They're really cheap. I think they're like $4 or $5, depending if you get the thing soldered on them before or not. And a couple basics of using a microcontroller. Again, there's a lot of stuff going on here, but really you just want to think about these pins coordinate to some stuff like digital in, which reads binary signals, so you can think of that on and off. I'm going to kind of quiz you on some of these later as we build our robot, so really commit this to memory. And then we have digital out, that sends those binary signals on or off out of the chip. And then we have analog in, it's going to read continuous voltage values into the microcontroller. And then we have something called pulse width modulation, which can get a little complicated, but you can kind of think of this as simulating analog out. You can do more than just digital out with your chip here. So if you want to control speed or brightness or something like that, often you're going to be using pulse width modulation. And what is MicroPython? So we tell microcontrollers how to do those things or what we want them to do with code. MicroPython is a version of Python that's incredibly lightweight. It's designed to run on microcontrollers. They say, I think, you only need 250K of storage space and then 16K of RAM, which is pretty small, but there's even chips that are smaller than that, so it doesn't work on every microcontroller, but kind of now if you're buying hobby ones like Arduinos and stuff like that, it's gonna run on them usually pretty fine. It uses Python 3 syntax, so if you're familiar with Python, is everyone here program in Python? I hope so. You're at the Python meetup if you didn't know. You can program in other languages too, that's great. So you can actually, on most of them, also program in like C or C++. And actually that can be a fun thing too. If you're familiar with Python, write it in Python, get it to work, and then maybe convert it to C if you want to continue into like the embedded space. Yeah, it's designed for microcontrollers that are low powered, like the Raspberry Pi Pico, et cetera. And then it has libraries. It has some of the standard libraries in Python, but also has libraries to interact with your chips. So we'll see this in action as we go. A little bit about the hardware setup at a high level. So we're going to kind of build that robot that I showed earlier. And the idea was I wanted to make a really affordable robot kit that people could put together themselves, or that I could host a workshop with, and it'd be like well under $20 or so. So we're going to use one Raspberry Pi Pico, one solderless breadboard. This allows us just to insert the components in. We don't have to solder anything, so you don't need any special skills there. One battery pack. This can really vary. I think it just needs to be like 5 or 3.5 volts coming out of it. 2 continuous servos. These are like motors that spin, except for they can spin in different speeds and different directions just on a signal coming out of the board. And then we have a couple resistors, which just allows us to lower power going to things like our LEDs. And then we have the 2 LEDs, which will light up. And we have cadmium sulfide photocells. These are like variable resistors that change depending on the light level on them. So, yeah.
Back to the Pico Pi, is that a 64-bit RAM, ARM, or is it a 32-bit ARM?
I don't remember. The RP2040, Andrew might know. 32.
Is there any sort of embedded operating system, or is this?
No, it's not. I don't think it's embedded operating system. Yeah. It's not like a full Raspberry Pi has an operating system on it, and then this is like their microcontroller subset version, like an Arduino, basically. And then we just have 2 pieces of guitar strings, or we can use switches. So you'll see I'll use the guitar strings to actually form a switch, and it kind of gives my robot like a bug-looking feature, which I kind of like too, but you could use switches instead. Putting the hardware together, almost no tools really required. That's why it kind of looks ugly how I made it. I just use like tape here to give traction on my servo. Like it came with these little parts, and I just use a little bit of hot glue. It's not like an actual tire or wheel that came in a set or anything like that. And then I didn't snip any of the components. I just put them in the breadboard. And maybe I cut the guitar string. I think that's it. And then here you can see this kind of creates a switch. This is a guitar string coming out of the breadboard. And then I have another little wire there, and when it gets touched, it closes the loop and actually creates a switch, which is kind of cool. And you can like adjust the sensitivity on here, and then I use a rubber band to really just tie everything together. Even though there is like a double-sided tape on this breadboard that would work way better. So if you don't have that double-sided tape, you can just really throw together this however you want. But you can make it like way cleaner too if you spend time on it. A little bit about the circuit. I guess depends on no mechanical tool.
That's a material.
I like that definition. I will actually post an actual circuit. I ran out of time to actually make one, a nice looking one. This is kind of, it looks together. You could totally read what's going on here, right? The main thing is really just the pins that we're connecting to for now. So the left wheel or servo is pin 1, pin 2 is the right, pin 15 is the red LED, pin 16 is the other LED, sorry, the right LED, left LED. Pin 26 is the left light sensor, 27 is the right sensor, and then we have the touch sensors, those guitar strings are switches, which is 14 and 13. So we need to know what pins these are on, so when we write the code, we can interact with them. All right, so let's program our robot. We're going to go through kind of step by step, but then eventually we want to build a thing that can drive forwards, backwards, turn, see light levels, and then the behavior we're going to program is like following light, but you could come up with other behaviors like going away from light or following a line. There's a lot of fun stuff you can do with all the things we're going to see here. And then it's also going to detect object collision when those touch sensors hit something. And then we're going to light up the LEDs on collision, but you can use those to communicate things from there. So let's make these LEDs blink. So we can kind of say hello with it. We're turning something on. Out of the things we talked about, not you, because I know you know this, maybe people who haven't programmed with a microcontroller before, what are we going to use? A digital in, digital out, analog in, or pulse width modulation to make an LED blink? Digital out is what I heard, and that's correct. So we want to use digital out. We're making something blink. We're sending a signal out, just saying on or off from the microcontroller. And then you can see in the code from machine, which is a MicroPython kind of specific thing, we're importing pin, and that allows us to tie things to those pinouts from our microcontroller. And then we're importing time, and then we're just assigning the pin 15 to 16 for the LED. We're saying we want this to be pin out, and then we just have a simple while loop here. We're saying start, When we turn it to 1, that means like on. So we turn them on, and then it waits for half a second, and then we turn them off. So now you've seen maybe your first bit of MicroPython.
Is there a reason you didn't want to go with PWM for this, or is this just to illustrate?
Well, I guess you might be able to do PWM, but you also don't need to for just turning something on and off and blinking it. The PWM is like you can have variations. Pulse width modulation. And I'll talk a little bit about that maybe when we get to it.
When I put my hand up, I didn't know.
All right, so let's add the touch sensors now. We're going to make the robot kind of feel with the switches. And now we're providing feedback into the robot. This is something that's on or off. Is this digital in, out, analog in, pulse width modulation? Digital in is correct. So again, we're just adding something on or off going into the chip. And similar to like we did before, we're importing pin from machine learning library, or from, sorry, not machine learning, the machine library. I work in machine learning a lot, so just slipping over there. And then we're defining the pins, and 14 and 13, we're saying it's in. Pull down means it starts basically at 0. Pull up is 1, so when it turns to 1 when they're touched, that would be pull up. And then we're just having a similar kind of while true, set the value, or if it equals to 1, that means it was touched, and then light up the LED. All right, so we're going to add the seeing capabilities here for light sensors. What do you think this is going to be? We have a light level. The light level varies. What was that?
Analog in.
Yeah, analog in. So it's not a clear like light or no light. It's like actually gets levels, and then we can see those levels, and you actually print them out. That's actually a nice thing too with MicroPython. Like when you're programming these chips, and if you connect it to your computer when you're debugging it, you can print out and actually see like light level variables and stuff, which is really helpful for debugging. But again, similar stuff like we saw before, setting the pins, and then we set them for ADC for analog in, 27, 26, and then here we're reading them with a 16 digit, or sorry, not digit, what's the word I'm thinking of? Yeah, 16-bit, unsigned 16-bit, thank you. So we'll get a pretty large variation of values from 0 to, was it 64,000, something like that?
655.
Perfect. So you'll get that level of variation based on the light level, and again, this is just like monitoring the resistance from the light sensors here. And then here we're just saying if the right sensor is greater than the left one, basically just turn on the LED and turn off the other one, else turn on the other one. So I'm just like flashing a light here, and it's turning on and turning off when it's lighter on one side. And one other thing we want to add to get to our kind of end result is drive the servos. We're going to turn something on, but servos are a little more tricky than just digital motors where you might have that out. So I'm guessing you can guess which one we use here, even if you're not really familiar with it. That's right, PWM, pulse width modulation. There's a little bit more code here. We're also defining the pins like we were before. Then we set something called a frequency. With pulse width modulation, they communicate at different frequencies. You can set this. Most servos are about 50. And then you have something called a duty cycle, which is how much you turn on during that frequency. And for servos, like I mentioned, usually they're like go from 0 to 180. But these are something called continuous servos where they can keep spinning like forever. And so you want to set forward to all the way to 20,000 milliseconds. We'll just always have it going forward. And then, 10,000 will always be going backwards. And then this 15,000 is like a neutral position, and they'll stop. So we kind of set these variables to those, and then we have a function where we're just saying stop is set to the stop variable, and then we have move forward, which is just them both going forward, and then we can have turn functions. In this case, it's just going backwards and forwards. And we're waiting like a half a second before we go backwards, half a second before we go forwards. Putting it all together, we have this little robot that, again, looks kind of weird, but you could build this yourself and make it look way prettier, and then let me know how much better yours looks than mine. But here we have it, it's following light. Hard to tell, but there's like a light over here, so it's coming this way, and then I kind of roll a ball in front of it, and it gets, presses in this kind of guitar string switch that I showed before. And can anyone read that? All that code? I was saying like, now that's MicroPython. Like that's, that's small. I was gonna open up this just on the GitHub, which also this is in GitHub if you want to go look at the code here. Also, I'm gonna update this repo later with like more instructions. So if you actually want to come build this on your own, you could do so. I'm gonna turn this way as I'm looking through the code real quick. But it's kind of all stuff we've seen before. We import the library, or import the types of things we want to do from the machine library, not the machine learning library. We're setting the servo left, servo right to the right pins, just like we saw before. This is nothing new. And then we're setting the servo frequency and the stop and forward and backwards times. And then we're defining all the backwards and right and stuff like that here. You could probably also clean up this code if you wanted to as well. And then we have our light follow function, which is we're just reading in like we were before, and we're saying if the light on the right is less than the light on the left, then we're going to turn. Oh, and I probably messed this up because when it says backwards in here, but this actually means forwards because the servos are flipped. And I should set the variables and make that make sense more in the code, but here I didn't do that, so I'll update that later too. So it says backwards, but that actually means forward for that right side. And then you can see this one, it's going forward. Oh yeah. Let's make this not so MicroPython. Is that better? And then we have kind of our initial setup. So this is when, this is in a main.py file that you just drag on basically to your Raspberry Pi. I'm actually talk about an editor that makes that way easier for you too as well. So when your Pi Pico starts up, it's just gonna run this file automatically. So this does a little bit of setup here. It does a little flash where it turns on all the LEDs initially. And then it sets the, it reads in the light sensor data. And then it sleeps for 2 seconds. So when you first turn it on, it's nice to be like, don't start running around right away. It gives me 2 seconds to kind of prepare for it. And then we print out the levels here. This is kind of for debugging. So if you were programming this, and sometimes what you'll do is like if you get 2 of those components, the photoresistors, one might be like way more sensitive than the other or have readings that are different. And so you can actually update, like kind of add some variable resistance into the code itself. So it's nice to like print them out and see what they actually read. And then we turn off the LEDs, and then this is our kind of main loop here. It's just a while true loop, so it's just gonna keep running. And this just says if the right touch sensor is touched, basically it backs up, it turns on all the LEDs, and then it backs up, and then it turns left. So it'll like run into something and then kind of try to go around it. If it runs into something again, it'll do the action again. And then it looks for touching right, does the same thing, but it turns left instead. And then we have oops, sorry. Then we have just, otherwise it's just gonna not go forward, but perform the light following function. So if it's brighter on one side, it's gonna turn towards it. Otherwise it'll turn the other way. Yeah. So yeah, maybe I didn't do a good job explaining it. When you are like programming this, you're going to get the file over to it, you're gonna plug it into your computer. And I'll show an editor that makes that really easy. Yeah, like you're gonna have a cord to it. And then, so it'll print out in a terminal on your computer that you're like pressing play in.
Can you do like OTA with wireless and that's
You might be able to. It has, I think this one, I forget if this one has Bluetooth. There's a version that has Wi-Fi, and I think you can definitely send something over it. I actually haven't done it, but yeah, I think you can obviously send something out of there and debug it that way. Yeah.
Earlier you mentioned the touch sensor. If it were like a pressure sensor, would that be analog since it's variable?
Yeah, that would be like an analog in. So there are sensors. There's a whole bunch of different types of sensors that you can use that we're not using here. And there's sensors that are pressure, and that would just be an analog in. And usually pressure stuff like that converts to like resistance, and you're just measuring a different number going into it. Some suggestions. So kind of like the, well, first, change the robot behavior. So if you build something like this, you can make it move very differently. You can add different behaviors into it. You can make it like follow a line, like I mentioned, instead of just following light. You just point those photoresistors down, and they can see like, is it a dark line or a light line, and then kind of move back and forth between it. That's a very common like getting started thing. There's this editor called Thani, which if you're kind of newer to the area, I'd recommend. It makes it really easy. It comes with all the libraries, and it has like the built-in debugger. So it's almost too easy. Like you'll take your Raspberry Pi Pico, plug it in, and at least for me, it usually just recognizes that it's plugged into a port, and then knows you probably want to connect to it. If you have multiple things plugged in, when you hit run, it'll ask like which one you want to run on. So it moves that file to it, but that's also where you'll get the debugging print statements that I had put in there, just in a terminal in there. And then, also a word of caution, maybe, if you're newer, is maybe use an inexpensive computer if you're connecting stuff to the USB port, especially if you're newer to circuitry and you think you might short something out and then connect it to your computer. You can blow out your USB port or damage your computer. It's pretty rare, but again, like word of caution. So if you mess around with it and you cross wires, you don't want to do that to an expensive computer. Has anyone ever done something like that before?
Not yet.
Several people, because I have, like, yeah.
They do make like USB protectors now that you can buy.
Nice.
Isolators or,
Yeah, it's like, it's nothing fancy. It's like a weird $30 dongle that, you know, in theory protects against this sort of stuff. Like,
You can also program this pretty fine on a Raspberry Pi, or like even a Raspberry Pi 3.5, which is pretty inexpensive. So what I've done is I'll have like stuff like that set up. Like this is my programmer computer that is okay if I accidentally broke it. So just a word of caution, hopefully pretty rare, but it can happen. Like I mentioned, if you want to get more into the embedded space and more in microcontrollers, you could try converting your Python script to C and C++ and probably learn a lot that way. Very different than just the microcontroller. It has a full OS, like you were talking about, is if you liked this, then you could try upgrading to something like a Raspberry Pi. You can program that not in MicroPython, but just in Python, but you'll have inputs and outputs, so you can actually build a robot that can actually do a little bit more processing power and use things like computer vision. And then mostly, have fun is the biggest suggestion I have for you. But one question is, who would be interested in doing this as a workshop through Puppy? So I know several people, like I've brought this around, and people really like it during programming nights, and they say, I want to build that. If we like brought all the parts in and then like had you kind of assemble your own version and then come up with a behavior, who would be interested in doing that as a workshop? Quite a few people, I think. So it'd be awesome, yeah. I think it'd be really fun and see like what people come up with, like almost like a little hackathon style thing where it's like, hey, we're gonna show you how to get started, how to build this, and then like, I don't know if we have a challenge or something like that and kind of see what you come up with. I think that would be really cool. BattleBots, yeah. We could do something like that, or like stay in a circle or something. We'll come up with some fun challenges, I think. And then thank you. And then if you want to connect with me, I talk a lot about robotics and ML stuff anyway. In my day job, I work with tools that major robotics companies and self-driving car companies use. And so you can come talk to me about robots any size. And then also I'll just mention we're hiring too. So if you're looking for a job, go check out union.ai/careers. And I think we have a software engineering position open, but also like an account executive, I think, as well. Thank you. That's my talk. I got sweaty.